welcome once again to Civil Engineering Today, brought to you by the Boston Society of Civil Engineers. I'm Cristina Fragoso.
And I'm Brockman.
And
today, our guest is Matt Taylor. So Matt is a geotechnical engineer who specializes in dams. And we're going to talk a little bit about dams today. And
welcome.
Thank you. Very happy to be here.
So once upon a time, the world, just the rivers flowed and there was no dams. So
right.
Where did dams come from? Why did people start building dams?
Dams were probably built initially for water supply purposes. Once the settlements grew and pulling water out of the rivers wasn't adequate, they also were built for industrial reasons. The Industrial Revolution prompted a lot of dam building, in particular in Massachusetts, and that's what are out there now. About a third of the dams in Massachusetts are leftovers from the Industrial Revolution, because they were powering mills that are no longer in place. And that has created a situation where we need to pay attention to some of these dams because they're 100 years old.
Is there still plenty of dams that are drawing power? Or
there are a few.
Massachusetts?
In Massachusetts, the hydropower population of dams is relatively low. More of those are out west where there are bigger rivers and higher flows. But here there are some. A lot of times there are mill structures that are left in place that have been converted into condos, and they have a antiquated hydropower unit that they're trying to use for powering their own facilities, but it's mainly just for green energy and not necessarily to offset the grid itself.
Now, some of these structures, you say some of these dams are still in place. Have there been so much infrastructure built around these dams in the past centuries that we just can't, remove the dam?
The removal process is something that's difficult. There's a permitting issue with it, and there's a lot of structural issues as well. There are times where you can't get to it, like you said, with access issues, but there's also times where there's contamination in the sediments behind the dam, so if you just take it out, you're going to have contaminants go
Industrial
downstream.
Revolution.
Yeah, exactly.
They were doing
it's
some crazy
great.
things.
It's great to remove dams, and we actually do quite a bit of that. But there's a lot of engineering investigation that has to go into that up front to make sure that what you're doing is actually going to improve the environment and not necessarily cause something that's going to harm the environment.
Right. Imagine when you pull a dam out, too, there's some major change that happens. I mean, water was held for a long period of time.
Right.
There must be some farmer or somebody that's going
down the road.
All that has to be assessed and
in
taken into consideration to make sure that you're not going to harm someone by taking out the dam. Most times the dams are taken out because they're in poor condition and they're being told by the state or by their own requirements for the public to protect the public to repair it. And the options are either to fix it or to remove it. And sometimes if the dam's not serving a purpose, then removal is the best way to go.
Are there a lot of them privately owned, or?
There's 2,900 dams in the Commonwealth of Massachusetts, and I think half are privately owned and half are either municipally owned or state owned.
And I know there's legislation in the works to try and get help with funding if they.
It was signed in January.
Thank God.
Yeah, right. And that's going to create some funding. I think there's $10 million for dams and $10 million for seawalls. And it's going to be a grant and a loan process to get some funding out there, because that's what's causing a lot of the holdback. When these dams are identified as being needed to be removed or repaired, the owners just don't have money.
Can you tell us about some of the types of dams that you see? Just in general, you can tell us general types of dams. Sure. And then maybe what's more popular in this area.
The main types of dams that we see in this area.
Too, here.
Sure. Will they?
Yeah,
it'll pop up. Okay. Types of dams will include embankment dams and gravity dams, and then combinations of gravity and embankment dams. And embankment dams are basically when they just take soil and fill a gap across a riverbed and impound water in a river environment. Gravity dams or concrete dams are ones that were built that usually for a narrower gorge. It was more cost effective, and you can get a bigger impoundment by building a larger concrete structure. And then combination ones are where they use the embankment dam to go across a larger area and then use concrete for the spillway, because even though you are damming it up, you still have to pass water when the storm comes.
Right.
And you need to have that go through an area that's not going to get eroded away when the waters do rise and go through the spillway.
I know those are popular in the Midwest, down in Texas. They need water, so
yes.
I did a big job on a dam down there. So tell us a little bit more about, as far as features, what is the dam doing? Like, how does it work, essentially?
Generally, dams serve several purposes. They may be for water supply, to create water for communities for drinking. There are some types of dams that are used for flood control, to deal with flooding that's going to go to an urban environment. And there are other dams that, for now, are holding back water for recreational purposes. And depending upon what the surface intention for that water body is, the dam type may have components that may or may not be part of it. So, like I said earlier, a spillway is usually a component at a dam, and that's to allow waters to pass through the dam and to be conveyed around the structure without eroding it during a storm event. The outlet works are ways to have pipes and low-level outlets to drain the pond for maintenance purposes, or for other types of releases. Sometimes you have to release water for the environment downstream, for certain fish flows, for certain fish populations. You have to release a certain amount of water. So if you just cut off a river and say, no more for you downstream, that's
Right.
that's
That's sort of
not
what
gonna
happens
work.
when people go whitewater rafting. They've been holding the water back in some dam for a long time.
Yes, and
everybody
I
rushes
didn't
out
know
there for the
that.
day of
Really?
release.
There's
Yeah,
a dam
yeah.
out in Western
Wow.
Mass. We actually wrote the paper on for Herzog, that they released water in October, and the kayakers come from all over, and they know about this, and it creates a whitewater environment that they just flock from all over to get
Right,
to.
for the day of release.
Yep,
Same thing up in
I'm
like
gonna
the
have to
Dead
bring
River.
my kayak over there.
sure.
No,
Yeah, but these guys are a bit insane, because they go through culverts.
oh, yeah,
you
no,
know,
no, no, no,
not,
no, no,
not
no,
much
I'm
room between the top of their head and the culverts, so.
Yeah,
you
seriously.
know, yeah.
Yeah, no, I'm not into that. But
So one thing like, why does a dam? I mean, what keeps the water from working its way through, especially if it's made out of just earth? I mean, concrete I can see being a little more waterproof, but even that doesn't seem totally waterproof. Why? And then water can work its way around. Why does a dam work?
There's a lot that goes into it. From an earthen standpoint, silty and clay materials are used instead of just straight sands. You know, if you think of being at the beach and you dump water in the sand, the water just
Right through,
disappears, right? But if you go into the woods, especially in the wooded areas around here, you have glacial till soils where are very silty, and the water won't necessarily percolate into very easily. Those are ideal dam building materials. Those may be built for the entire dam structure itself, or they may be built right in the middle as a core. So you may have a sand and gravel or a rock face on the outside, but you have a core barrel, a core material that is fine grained and water can't pass through it. And usually the dam construction process involves digging down to a material that's of similar permeabilities, whether it be bedrock or down to a clay or to a till material, and you key it in on the abutment so that the water can't work its way around. So same thing with an earthen embankment dam as well as a concrete dam. The foundation prep and the abutment prep are keys in order to make sure that the water doesn't have a way to get around the structure.
Right, so it's sort of like the same as like a clay pot. Like water doesn't go through a clay pot, so why should
Right.
it go through a clay dam?
Right.
Same general feeling.
now, who's a better dam builder, humans or beavers?
There's a lot of battles out there that occur where the beavers are always trying to compete with us. We have better resources, so our dams can last longer, but they are, nature's dam builders, and they do create situations more of a nuisance for humans than the benefit for their own community, but they do work as we see. And
Right. How does that work? I mean, it's just they don't have clay. They've just got wood.
No.
No, I think they use.
Well, they sometimes use soil. Sometimes they use, say, wood, timber as a frame, and then use some mud, use some leaves, just enough to create a seal. That's all
Right.
it takes. And if you can use the water pressure to help push up against it, you're using some of nature's benefits there.
Sustainable design.
Yeah, exactly.
seriously, they're
Green
seriously
dam
smart.
building.
Smart
right.
critters.
So what are the animal burrows built into? I see on the features slide
Those
here. you have
aren't necessarily a feature as they are as much a deficiency. And
Oh,
that's
okay.
something that we look at on an earthen embankment. If we start to see animal burrows, that's a bad thing, because if an animal's burrowing through and potentially hits into that
right.
core wall, then you could potentially get a leakage situation there. So when you start to see animal burrows, that's one of the things that the dam owners need to be vigilant about, to make sure that they take care of these dams and take care of situations like that. As that, along with unwanted vegetation, trees growing on dams aren't
Oh, right,
necessarily a good thing.
the roots digging
The
wherever
roots
they
can
wanna go.
die, they can create flow paths, they can topple over, carry root balls to lower the crest of the dam, so during a storm you can get overtopping. So there's a lot that happens in these earthen embankment dams that the owners need to be aware of and plan for and take care of them in a way in order for them to perform adequately.
Right?
Now, is there a standard as far as how often they need to inspect, or is it regulated? There's a federal regulation every 3 years.
In Massachusetts, it's state regulated, and the inspection criteria are based on the hazard class. And the hazard class doesn't mean that the dam's in bad condition. It means if you have a big dam and you have a house at the toe of it, that's a high hazard dam.
Yes.
If you have a dam with a field and it ends up running into the ocean, that could be a low hazard dam because the impacts to human life, if it were to fail, are lower. So for a low hazard dam, you inspect it every 10 years, but for a high hazard dam, it's inspected every 2 years.
But we do
But-
have 7 high hazard dams. How many high hazard dams
I
do we
think
have?
there's over 400
Right, there's a lot of high
dams.
hazard
Yes, oh yeah.
It's pretty, I mean,
7%.
Yeah.
That's what I meant to say.
Well, oftentimes there's, especially in Massachusetts, because of the way in which these dams were built, there's hazard creep. So in 18-something, a dam was built in the middle of a forest or a field. Well, that area's been settled since
Turned into
then.
a
So
residential
now
neighborhood.
there's a subdivision at the toe of that dam. So now that dam that was intended to protect the fields, and if it overtopped and flooded their fields, the farmers said, well, that's the way it is, no big deal. Now, that overtopping event could cause loss of life by flooding out houses.
Now, I'm looking at these slides here of the dam inspections. Is that you? That little
No, that's
tiny-
not me.
Oh my gosh.
That's a coworker. We do rope access on the larger concrete dams to inspect the structure, the joints, and the condition of the concrete, condition of the masonry. It's a great gig if you can get it, and you're qualified for it, and if you want to do it.
yeah, I've done a couple, it's fun.
Yeah.
So the parts, I mean, if we go back to that nomenclature, we never really, what's the top of the dam and the ends of the dam and
The ends of the
what
dams
do you call them?
are abutments, where similar to a bridge, where the dam ties into the high ground on either side of the dam. The toe of the dam is at the bottom of the slopes or at the bottom of the concrete. That's where you'll have to keep an eye out for seepage issues. If the water is starting to work its way through the dam, that's where it'll show up first, and that's where you'll have to start to take action to hopefully address an impending dam failure. If you start to see seepage in an uncontrolled way down at the toe, that's when things have to start getting elevated, and you have to start reacting to protect the dam. Trying to think of the other components to it. The top of the dam essentially is the top of the structure. It's the highest point which can impound water.
Yep.
So you have the top of the dam, you have the top of the spillway, that's where it normally sits. If a flood comes or a rain event comes, water will spill over the spillway first before it gets to the top of the dam. If it starts to spill over the top of the dam, chances are you've exceeded the hydraulic capacity of the dam and you have an issue on your hands. So most of our work now at this age is trying to address hydraulic issues with these dams because they were designed back turn of the century without the methods that we have now. Some dams were great and they were just built large enough and they were able to take it. But now with our understanding of hydraulics and meteorology and with the increase of extreme storm events, this is becoming an issue that we have to come up with creative ways to get water through the dam without overtopping it and causing a failing condition.
There are almost on every show we've had concerns based on weather, the weather. There's a change in weather. Now I see here, this is in speaking of weather, massive rain events. I see sinkhole. Is that typical in Massachusetts to see sinkholes?
It's not a sinkhole like you see in the Midwest where
Florida
you
or
No,
have
like the one that just swallowed
Soft
the
limestones.
condo complex in
It's,
Florida.
We have all court.
The sinkhole is again a deficiency, and it's usually caused by something happening in the dam that wasn't intended. Like say a pipe goes through the dam, the pipe gets a hole in it.
Oh, all right,
Material starts
okay.
to migrate into the pipe. It manifests itself at the surface of the dam as a sinkhole.
Okay, so it's any hole
it's
that
a hole,
causes things to
exactly.
sink in.
I was going to say, I haven't really heard of many sinkholes here in Massachusetts.
No.
Unless there was a
Yeah, you
water
get down
main
south and you
break,
get that
something,
salt.
you know.
You know, you get the limestone ground, that's different.
Yeah.
We do have some in New York and Pennsylvania. There is karst topography or karst geology up there where you have to deal with that, and foundations of dams that are on that require quite a bit of treatment because sometimes you need the impoundment where it is, and if the bedrock is karst, then you have to deal with it. and it's dealt with grouting and things like that to create the seal.
So impoundment, that's the water that's held back behind
Yes.
the dam?
Yes.
Okay. Just
And
checking
when
on
you mean grouting, can you explain what you mean? I mean, we see here some rehab. I don't know if you talk about different types of rehabilitative.
As I said earlier,
designs.
there's a core wall is a key component to retaining the water in an earthen embankment. If that core wall has deteriorated over time, you have to replace it. And usually taking the impoundment offline, draining it, is not necessarily something that we can do from an environmental standpoint because there are fish and wildlife in there. So we have to do the work while keeping the impoundment in place. So we have to fix the dam as is. One option is to go in and to recreate the core wall by using grout. So you drill through the top and create grout columns through the embankment, usually down into the foundation. If the leakage is getting underneath the dam and showing up further downstream, then maybe the grouting depths need to go deeper into the bedrock.
Is the grout material sort of like clay? It
Yes.
functions similarly?
A bentonite grout, so it will expand. It's really just intended to provide that seepage, and it's really not as much of a hard science as it is a bit of a balance where you grout, see how it performs, grout again, until you get the leakage to where you feel comfortable with it being.
What other sorts of methods do people usually use to repair a dam, depending on the deficiencies? And
Sometimes you're building a coffer dam upstream of the dam where you're
Oh.
essentially cutting it off, putting it in the dry, and then you can reconstruct the whole thing. If the dam's really long, then that doesn't become very cost effective. If the dam's in a really deep impoundment, then a large cofferdam may not be cost effective. It may not be something that they can deal with in a flooding situation. They can't pass the water through the area. Sometimes they have to leapfrog it, do it in pieces, and you can reconstruct the dam that way. A lot of times in Massachusetts and in New England, the farmers were building these dams by hand, so they didn't put a lot of material into them. So they have steep slopes, narrow cross sections. When you do slope stability analyses, you find that they're not stable, so we have to widen and flatten them. So sometimes we're just widening the toe, making the slope flatter, creating more mass, creating more material to hold back the water and increasing the stability. That's usually done with just earthwork excavation and equipment. Going into the impoundment, something that's usually not done because there are regulatory issues with that going into the impoundment and permitting issues associated with that. But a lot of times the work is really focused on the spillways and getting that hydraulic capacity increased. Once that's addressed, a lot of the stability issues go away because they're made worse by water going up and over the dam itself.
So before the show, we were talking a little bit about, and it was great because I could really understand how a dam works by it. You were talking about that you brought a clear plastic box
Yep.
into your kid's classroom.
Yep.
And want to explain that one a little bit and like what you learned when you were telling me there was a. Well, I'll let you talk.
Okay. 2 years ago, I did a exercise with my daughter's first grade class. I brought in a large Tupperware box, 1.5 feet wide, 3.5 feet long, foot tall. And I brought in sand, I brought in modeling clay, I brought in lots of buckets of water, and I split the class up into two groups, and I said, who wants to build a dam that's going to fail? And half the class raised their hand. And who said they want to build a dam that's going to work? And the other half raised hands. So that was great. I split them up into two. So I had one group of kids build a dam that was going to fail, and we built that just with sand. So we built the dam with a typical cross section. I think we put 2-to-1 slopes and say a 10-inch wide crest on it, just with sand. And we filled up one side of the box, and you could see the water working its way through the sand, and it was great because the box was clear, so you could see the water going through the soil. And from a theoretical standpoint, this is what we've read, and you believe it. But now I get to see it for real, which was great. So you could see the water working its way through, and as it got through the embankment, it got down to the toe, and you started to see it seeping through, just the way you would see it at a beach, where the water would go through the sand, it would just fly through, and it would start to unravel. And what that
So
created
the sand
was
actually is spurting
the water.
spurting
The water started carrying the sand out, and then it led to what was called a progressive failure, where a small slope failure happened, and another one, and another one, and another one. Eventually, it cut all the way back through the crest of the dam, and the whole thing carried through. So you get to see that sand wasn't the ideal material to build the dam. So with the other box, we put a clay core in the middle, and the kids could see the water fill up through the sand after we added up on the impoundment side. It saturated the upstream side, but the clay cut it off, and it retained it. There was no seepage on the downstream side, And it really showed the kids that, the material selection was key in making this project work. And for me, and for my own satisfaction, it was great because I got to prove something
Yeah.
Right.
that, sometimes we design these things and we're, cross our fingers and say, I hope I didn't miss something
It's
here.
hard to do geotech experiments. Absolutely.
Yep.
I tried to do some in landslides with the big shake tables.
Yep.
Oh my God, big pain in the neck.
Yeah, I mean, an earthquake's kind of an extreme, but how do the dams hold up in an earthquake, speaking of that?
Certain dams will do better than others. There are some dams that are, the core is actually built with what's called a hydraulic fill core or a puddle core. And they sluice fine-grained materials into an underwater environment where they're building 2 embankments on either side, and they sluice in silt and clay to settle out. So that material is very unconsolidated. So if that's ever hit with an earthquake, that's going to go pretty quickly.
Right.
So there are some dams that have that as an issue, and there are some dams that have concrete without reinforcing issues that also have issues during seismic events.
Well, I feel like the show was pretty good. We got a good idea of dams, but we'd love to go in depth. I would love to actually slowly maybe do a film of a project on when you do a rehab maybe, and then come back and explain to us the specific project, just so
Exactly,
because it is
that'd be
difficult
awesome.
to explain.
That'd be great.
Earth theory. It's
Right,
just
right.
hard.
And
You
I
can't
just-
really see what's going on.
Before we wrap up, I just want to make a couple of announcements. First,
Okay.
congratulations on getting the Herzog Award
Yes.
for your paper on
It was a great paper.
It was on Otis, the dam out in Otis.
Yep.
We'll see it. Is it
Otis
called-
Reservoir Dam.
Otis Reservoir Dam, correct.
Owned by the DCR.
And Bill Zoino is going to be one of our distinguished members, and I want to congratulate GZA for all the great things that they're doing and all the great projects and keeping the community safe.
Great.
Quick shout out to Wareham, where I was today with the Teachers Island Southeastern Mass, with the 100th anniversary of the Cape Cod Canal coming up. We're hoping to get a lot of great activities and get a lot of the schools involved in the Future City program. All the outreach programs going to be starting up again, and thank you to all the schools and camps and groups that have come out on the tours of Boston Bridges this summer. For anybody interested in doing any of that, please visit www.engineeryourfuture.org. And again, thank you very much, Matt.
Thank you for having me.
Thank
I
you. It
appreciate
was great.
It's great. Thank you.